All right, for this bell work, let's get it put into slope-intercept form, which hopefully remember y equals mx plus b. So the reason why we want these in slope-intercept form is because if they are, then we can graph them as well, even though this one's not asking us to graph it. So it's just some decent practice right here. So when we start, we use some principles of equality here. Let's get rid of that 3x, which will then allow us to just drop the 6y so that it's by itself. We got to zero out that 3x first. So by zeroing it out, that means we'll have to use addition or subtraction principles of equality. I'm going to use subtraction. It is a principle of equality, so if you do it to one side, you got to do the other side. So this will zero out the 3x's, and then I can drop the 6y by itself. Now, on the other side, I'm going to just reorder these so that my x term is first, and then my constant is second. But make sure you don't combine those because they're not like terms that you can combine. So one's an x term, one's a constant. Keep them separated. And then, unlike before where we would say just divide both sides by the coefficient in order to make the coefficient of y a phantom 1. Right now it's a 6. We're going to make it a phantom 1 though. But we're going to do that by dividing all the terms by that coefficient of 6. Now this is the same thing as dividing both sides by 6, but on the right side we've just split it up into two separate divisions, and that's okay too. So 6 divided by 6 is 1. Of course I'm going to make it a phantom 1, so it looks pretty much like the slope-intercept form. And we're going to have x's, but how many x's? Negative 3 over 6, negative 3 divided by 6, that would be negative 1/2. And then negative 30 divided by 6, that would be negative 5. So this is slope-intercept form here. And again, this would tell us directly what the slope is and what the y-intercept is. And then we should be able to graph that. I can write equations in slope-intercept form from a graph, or 2 points, or slope and a point. So we're going to see these differently, but we should be able to do all by the end of the class. We're going to need some slope formula to do this, and then we're also going to need a y-intercept formula as well. So take 30 seconds, copy this down, then we'll get started. So slope formula, remember it's y's over x's, because the y's represent the rise of the graph, and then the x's represent the run. Okay, not the runs, just the run. So the rise, the y's are up and down, that's why they're the rise, and then x's are the run because they're left and right. But this would come from two ordered pairs that we're going to have. Now it doesn't matter which order you put these in. It's just important to remember that you're going to have an x value and a y value in one ordered pair, and then an x value and a y value in the other ordered pair. But when you list these ordered pairs in the slope formula, remember x is in the denominator, y is in the numerator, but then also corresponding pairs have to be above and below each other. Okay, so what you'll see is I'm going to try to color code these, and I'll say, well, I'm going to put my green ordered pair first, and then my orange ordered pair second. But it doesn't matter which one you put first or second, because it's always going to be subtraction between them, and it's subtraction because it's a distance between the x's and the y's separately. But then we combine them into a ratio, like you see here. When you're putting these in the calculator, remember that we're going to be using parentheses around the numerators and denominators, and then the fraction is just the divide button right there, okay? So my recommendation, since we're putting this into the calculator, just keep the parentheses where they are, and that's okay. Okay, but and then keep the signs how they are. So if y, let's say the orange y right here was negative, don't change this to a plus, because sometimes that can confuse us. Why is this showing as plus? Or maybe some students still put plus a negative, which it shouldn't be. Okay, so just type it in exactly like we see it into the calculator. Okay, now the last thing is we've seen a lot of mistakes where students are putting the x's on the top and the y's on the bottom. Remember, it's rise over run. So the y's go on the top, x's on the bottom. If you make that mistake, you're going to get the wrong slope, even though your numbers may be correct. They're just in the wrong position of the fraction. So be careful. Y's on the top, x's on the bottom. So slope formula, we're going to be using this. And the other thing that you're going to need to write an equation, you need the slope, of course, and then the y-intercept. Why is that? Because it's y equals the slope times x plus b. So once you find your slope, you just insert it as the coefficient of x. And once you know your y-intercept, then you just insert it as the plus b part of it, okay? Now, we already know how to find the slope, but the question becomes, how do you find the y-intercept? Well, as it turns out, we find the y-intercept by using a literal equation. So we're going to take this equation, y equals mx plus b, and what we're going to do here is we're going to say solve for b. Okay, so this goes back to 1.8. I'm going to manipulate this equation for b, okay? Now this isn't too bad because from here I can do this with one principle of equality. If I'm going to solve for b, then I just need to zero out the mx, which then allows me to drop the b. Then I get b equals, okay? I'm going to write this two different ways, but it's the same thing, okay? So to do that, I would have to zero out my mx, right? Well, to do that, I would have to subtract mx from both sides, like this. And I'm going to change the order just so it looks pretty. But this means you got y minus the m times the x. And this has been solved for b. But like I said, I'm going to do it again. I'm going to write the equation again, just slightly different. If I want to solve for b, which is the y-intercept, I'd like to see it like this. b equals y minus mx. Okay, now we know how to find the slope, right? But the question is, well, what do we do with the y's and the x's right there? Well, that comes from one of the two ordered pairs, right? So we're going to have two ordered pairs. Again, I'm just going to make them green and orange. So you're going to have an x and a y value there, and an x and a y value there. Doesn't matter which one of these you choose to find your y-intercept, because the y-intercept and these ordered pairs will make the equation true, right? That's what a solution is. So it doesn't matter if you choose the green one or the orange one. I tend to choose the green one. But once you know your green ordered pair or the orange one, then that x becomes that x value, and then the y becomes that whatever that y value is. So this becomes kind of like a formula that we just start replacing these with numbers, and then it solves directly for b. Now you could have just used slope-intercept form and replaced the y's and x's and m up here, and then solve for b, but the formula kind of takes away that step. Okay, so this formula, we're going to be using it. This is my y-intercept formula. The x and y are values that you could have replaced in whatever the equation is to make the equals a true statement. So it's going to be true down here for the y-intercept. That's why it doesn't matter which point you choose. Here's an equation. Let's write the equation of this graph, and we will write it in slope-intercept form. Y equals mx, where m is the slope, and then plus b, that's my y-intercept. Now on a graph like this one, when you look at the graph, that's all you really need to do to find the y-intercept. Just look at the graph. Where does the graph go through the y-axis? And I can see it's going through right here. So what is that point? They've even kind of given us a point there, but I'm emphasizing it. That looks to be at the point 0, -2. All right, so my b up here, I'm going to go in, and I'm going to replace it with the y value of the y-intercept, which is -2. Well, thank you for that, but now what we need is to find the slope, right? Now there's two ways to find the slope. I'm going to do it both ways, and the first way is to use the slope formula. Now the only reason why I'm using two different ways here is because it's a graph. If it was not a graph, I would have to use the slope formula. But I'm going to show you two different ways if they do give you a graph, which they will on the assignment. So I have my purple ordered pair there as the y-intercept, but I have this other point right here, and that appears to be at the location -6, 3. Okay, so again, I've got my x value and my y value. So I go into my slope formula, I put the x in the denominator, which is -6, and the y is 3, it goes in the numerator. So the other point I have is the y-intercept. So I got my x value 0, I put that in the denominator, and my y value is -2, it needs to go into the numerator. Okay, now when you put this in the calculator, don't forget that the numerator needs to be in parentheses, these calculators that we have. So parentheses 3 minus -2, and those are different buttons. Then the fraction line, you're going to have to use the divide symbol button. And then you need more parentheses for the denominator, -6 minus 0, close parentheses, you push enter. Let's see what this gives us. So my calculator gives me negative 0.83 repeating. But I don't want that decimal because I want to see this as a fraction. So I'm going to push on the calculator math. That's 3 buttons down from the top left. And then enter in the bottom right. I push math, enter, and it says your fraction for that decimal would be negative 5/6. All right, and that would be my slope, negative 5/6. If we've done this right, this means that you would have gone down 5 and to the right 6. Of course, it's already graphed for us, but just a quick review. So I'm going to go up here, I'm going to take my m, the slope, and I'm going to replace it with the value we found at negative 5/6. And this is the equation in slope-intercept form. So we know the slope, negative 5/6, but like I said, you could have found that on the graph. You could have used this point right here as well. You only need 2 points, but this is the ordered pair 6, negative 7, it looks like. But from here, I just use rise over run for this one. So I say, look, go down and then to the right to get from one point to the other. This one shows that you would go down 1, 2, 3, 4, 5. So we went down 5. That's where the negative 5 numerator comes from, here. And then it goes to the right. But how far does it go to the right? Well, 1, 2, 3, 4, 5, 6. To the right 6, that's our denominator, rise and run. And then you would have gotten the same exact slope. So when they give you a graph like this, like I said, you can just use the graph if you'd like. To me, it's faster, but like I said, we won't have this luxury in the future. They're not going to give us the graphs. They're just going to give us 2 points. Then we got to write the equation, which is part of the objective. So one part of the objective, can you write the equation from the graph? Well, we just seen this example, but now we got to see, can you write an equation from 2 points? One of the main things we've been seeing on this is instead of this fraction, the students get the 6 and 5, but they have it switched. So they have like negative 6 over 5. And the line would even look similar to this one, but again, you've just reversed where the x's and y's are in the slope formula. Make sure your y's are on the top, x's are on the bottom. So this one, we have 2 ordered pairs, and like I said, I like to color code these. So my first one here is going to be in green. X is negative 5, y is negative 2, and then this next one, x is 0, y is negative 6. So when we go to find the y-intercept, it doesn't matter which point you use, but I'm going to start with the slope, right? So we want this equation to be in slope-intercept form. That's y equals mx. M is the slope, mx plus b. And the plus b part right there, that's my y-intercept. So I'm going to start with the slope. You could start with the y-intercept, but you need the slope in the y-intercept formula anyways. So right here, to find my slope, I know it's a fraction, and it's always subtraction between your y's and x's. Y's in the numerator, x's in the denominator. So you can even make a note like this, something like that. So I'll start with my green ordered pair, but you could start with the orange one if you'd like. So the green ordered pair, my x is negative 5. It goes in the denominator. My y is negative 2. It has to go in the numerator. Y is in the numerator, x is in the denominator. Now my orange ordered pair, the x is 0. It goes in the denominator. And then the y is negative 6. It has to go in the numerator. So we know we just take the calculator to put this in. Just make sure when you put it in the calculator, you put parentheses around your numerators and denominator. The fraction line there is just a divide button. So parentheses, negative 2 minus negative 6, close parentheses, divide by parentheses, negative 5 minus 0, close parentheses. And this tells me, hey, your slope as a decimal is negative 0.8. I don't want the decimal. Okay, so again, this is where we go. We push math, enter, enter on our calculators. And it says your slope actually is negative 4/5. Now, of course, it's not asking us to graph this. But if it was, we know it would go down 4 to the right 5. But up here in my slope-intercept form, I'm going to replace the m with the value we found as the slope as negative 4/5. So all we need now is the y-intercept. So we go to the y-intercept formula. The y-intercept is represented by b in the slope-intercept. So from here, remember, all you're going to do is you're going to take the y value and subtract the slope, and that's multiplied by the x, okay? So we just found the slope with the slope formula, so that's the m. I'm going to replace the m, the slope, with -4/5. I'll put it in parentheses when I put it in the calculator, otherwise it may interpret that incorrectly. And then, right, the x and y, that comes from my ordered pair. And I'm choosing the green one, just because I put these in green. But again, the orange one would work just as good. And so the x value in that green ordered pair, as we've seen already, is -5. And then its corresponding y value is -2. So I take the y, I replace it with -2. And then I just put this into the calculator. It should tell me right away what the y-intercept is. So -2 minus -4/5, in parentheses, by the way, times -5, enter, and I get -6. Okay, so that, I mean, it kind of looks like a 6 already because my handwriting sucks. But I'm going to take that b, or the plus b, and I'm going to replace it now with a -6. Okay, and this would be the slope-intercept form of the equation. Now, you see how I got 0, -6 as my y-intercept? Some of you may have noticed that it gave us the y-intercept in the beginning, right there. But I did this on purpose, because if you didn't notice, then you would have to use the y-intercept formula to find the y-intercept, and then you're good. So like this one, same idea, right? We're going to find our slope-intercept form on this, which is y equals mx plus b. Okay, where m is the slope and b is the y-intercept. All right, that's good. Let's start with our y-intercept. Let's not start with the y-intercept. Let's start with the slope. So I take my slope formula. I know it's y's minus y's over x's minus x's. So y's over x's. But I need ordered pairs for this, right? So I've got my first ordered pair. Again, I'm putting it in green. I see the x is 4 and the y is -7. So the 4 in the denominator, the -7 in the numerator. I've got my other ordered pair where x is 8 and the y is -6. So again, the x in the denominator is 8 and the y in the numerator here, -6. So as we've seen before, I'm just going to take this. I'm going to put this in the calculator, but I'm going to put my numerator and denominator in parentheses. Let's see what we get. Parentheses, -7 minus -6, close parentheses, over 4 minus 8. So divide by parentheses, 4 minus 8, enter. And my calculator says your slope is 0.25, but I want the fraction form of this, right? So math enter, enter, and it says it's up 1 to the right 1/4. So I go to my slope-intercept form. I take my m, the slope, which I've just found as 1/4. The only thing I need now is my b, which is the y-intercept. So I say b equals y minus mx. And again, the y and the x come from the ordered pair, which I'm going to use the green one, but the orange one would do just as good. And then the m is the slope, which we just found. So the m is the slope. I take it, I replace it with the slope I just found is 1/4. When I put that in the calculator, it's a fraction, so I'm going to put it in parentheses. And then I can see up there, again, I'm using the green ordered pair, the x is 4. And then the corresponding y value there is -7. So I'm putting these in parentheses almost out of habit, but you don't necessarily need to, the green numbers from the ordered pair. But definitely in the parentheses for the fraction, I recommend that, okay? So when I put this into the calculator, I get -8. Okay, so my y-intercept, instead of it showing it as plus b, it's ended up going to be minus, because it's a negative value, it's a -8. That's it. So this is my slope-intercept form here. This one, don't get this. This is not a y-intercept here. This is an x-intercept, because the x is not 0. So that's not going to help us when we want the y-intercept. But what we do want is slope-intercept form, right? So I say slope-intercept form, y equals mx plus b. And I know m there is the slope. And then the b is the y-intercept. Once I figure out the slope and the y-intercept, I just replace the m and the b, and then I have the slope-intercept form. Okay, so let's start with the slope, as we have been. Slope, that's where we're going to take the x's and the y's and subtract them. Y's in the numerator, x's in the denominator, which we need to remember. So here, I have an x value that's 4 and a y value that's -3 from the ordered pair that's given. So the x in the denominator, the y in the numerator. 4, -3. Then I've got my other ordered pair, which shows that x is 2 and the y is 0. So x in the denominator is 2, 0 in the numerator because it's the y value. So I'm going to put this into the calculator. Again, I'm going to put the numerator in parentheses. And I'll put the denominator in parentheses as well when I put this in the calculator, right? So I got parentheses, -3 minus 0, close parentheses, divide, parentheses, 4 minus 2, enter. And so this one says your slope is -1.5, but then I push math, enter, enter, and it changes it for me into -3/2. Okay, so my slope, I know, -3/2. So the m in the slope-intercept form, I now change it to -3/2. And again, we would know that'd be down 3 to the right 2 if we wanted us to graph it. But then I need my y-intercept. So that's where I take the y and subtract the m, which is the slope, times the x. Okay, so we have all three of these values. Again, we just found the slope as -3/2, which since it's a fraction, I'll put in parentheses when I put it in the calculator. And then, this time I'm going to actually use the orange ordered pair just to show you it works. The x value there is 2, and then the y value is 0. Okay, so on the calculator, I type in 0 minus -3/2 times 2. Again, my slope there, the fraction, I'm going to put in parentheses. That gives me +3 on that. So since I got +3, I'll keep the plus sign in my plus b, but it's just +3. And again, this is my slope-intercept form. So what would have happened, let's go back. What would have happened if instead of I used the orange ordered pair, would I have gotten the same value if I had used the green x and y? The green was 4x, and then the y was -3. Yeah, if you had done this, you would still had gotten 3, okay? So this one, we want slope-intercept form, right? Y equals mx plus b, where m is the slope, and b, the plus b right there, so y-intercept. Okay, but first we're going to need to find the slope. So I say my slope, here we'll use the slope formula because they've only given us 2 ordered pairs. It's always subtraction between the y's and the x's. Y's in the numerator, x's in the denominator. And here I see an x value that's -7 and a y value that's 3. So remember, x is in the denominator, y is in the numerator. -7, 3. And I have my other ordered pair, 5, 3. So x is 5 here in the denominator, 3 in the numerator. So once again, when you put this in the calculator, again, make sure you put your numerators and denominators in parentheses because there's operations there. Then the fractions line is your divide button. When I put this in the calculator, I get 0. So my slope here, I'm going to replace with 0. That's nice. But now what do we do? Well, we got to find the y-intercept b, which is just by taking the y value and subtracting the m value times the x value. So m is the slope, which we just found. That's 0. So I replace m there with 0. You can put it in parentheses if you'd like. Then I have an x value from my green ordered pair. Thank you. Is -7. And then the corresponding y value there is 3. So replace the y with 3. And put this in the calculator. When I put it in the calculator, I got 3. So up here, the b is a +3. I replace it with 3. Just be careful because I'm not sure that it may not accept this because it's not considered fully simplified, okay? This is one of those situations where the slope is 0. So we're actually looking at what would be a flat line. Okay, because again, the slope is 0. There's going to be a flat line. Horizontal line, where y is 3. And so this would be the more simplified form of that equation. Now, this may take some experience, but for those of you that noticed how the y's repeat as 3, that's an indicator that the equation is just y equals 3. So if you notice that, you're welcome to just skip all this garbage. But if this stuff helps you, then do it. Okay? If you don't notice that, you don't have to go through this process. You're going to get the same answer. Now they're giving us a point and a slope, right? So that our objective was, can you write an equation from a graph, which we've done? Can you write an equation from 2 points, which we've done. Now we have the point and a slope. So on this one, though, they've given us a slope. So when I go to my slope-intercept form, right, y equals mx plus b, where m is the slope, and the plus b part right there, that's my y-intercept. I already have the slope. I don't need to find the slope anymore. Okay, so I don't need slope formula. I don't need to look at it on a graph. It's just giving me the slope right here, -3/2. What I need then is my y-intercept. So I go back to my y-intercept formula, though, where I take the y value and minus the m, the slope, times the x. And again, this x and y come from the ordered pair that's given. X is -6, y is 5. So I already know my slope. Let's go and replace that first. That was a -3/2. And then I have a corresponding, well, I've got a x and y value, corresponding x and y values. And my x there is -6. And my y value is 5. So take the y, replace it with 5. This gives us the formula for the y-intercept. Just plug this into the calculator, okay? So I've got 5 minus parentheses -3/2, close parentheses, times -6, enter. And it says your y-intercept here is -4. So again, it's a negative, so it's going to be -4. And this is my slope-intercept form. Okay, so it's nice when they give us a slope because it takes away the need to find the slope with the slope formula, but you still need to find your y-intercept on these. So we need to be able to write the equations with the slope and a point. So some of these times they're going to say, well, the slope is 0, right? Okay, well, what's the equation then? Well, we know that a slope that's 0 will produce a flat line. It's automatic. 0 slope, flat line, because that's the no slope. If that's the case, we're going to look at the equation as being y equals. Okay, now on the graph we would say find the y value on the line right here, but they're not going to give us a graph. They're going to give us an ordered pair. But we know in the ordered pair that it's going to have an x and y value. It's just whatever the y value is. Okay, so whatever this y value is, that's what y equals in the equation. Okay. Now, if the slope is, it says D&E, does not exist, it'll probably say something like undefined on the assignment. If the slope is undefined, then you're looking at a vertical line. So an undefined slope will give you a vertical line that's straight up and down. And we know that then would give you the equation x equals, okay? But what would x equal? Again, you could look at the graph and say that the x value on the line, but now we're looking for the x value in the ordered pair, okay? So this may not make a lot of sense, but let's look at some examples then, okay? So this one right here, it says the slope is 0. So right there, that tells me my equation is y equals a number. Well, what number is it going to be? It's the y value in the ordered pair, which I find right here is 5. So the equation is just y equals 5. That's it. Okay, so slope of 0, again, that tells us it was a flat line. And we know flat lines have this form of the equation, y equals some number. For this one, here it says the slope is undefined. So this one would be a vertical line. And we know vertical lines take the equation x equals a number. But again, what number is it going to equal? Again, just look at your ordered pair. I have an x value that's 7, so x equals 7. That's it. There's our objective again. I can write equations in slope-intercept form. We did it with graphs. We did it with 2 points. We did it with slope and a point, even when the slope was 0 or undefined. So if you guys feel good about that stuff, the assignment's going to go great. If you don't, you need to ask questions.